Example 2. Rewrite the function f in the form y equals k over x minus m plus n. So now the reason for this example is that all these functions you see here are the rational functions. So the functions in the form y equals ax plus b divided by cx plus d. And the whole problem that we have to solve here is to learn how to sketch graphs of these functions. What we know at the moment is how to sketch the graph of the function in this form. Now, this exercise serves the purpose of showing how to transform this graph, the rational function or the equation of the rational function to this form, which then helps us to sketch the graph quickly. So let's start with with the part A of the exercise. So in part A, we have the equation y equals x minus 1 over x minus 2. So this is actually a rational function, and all we have to do is to transform it to this form. So to do it, I will use some neat tricks. First of all, I will use the trick of trying to replicate the denominator in the numerator. So you see that in the denominator I have x minus 2. In the numerator I have just x minus 1. Okay, so let me add minus 2 and plus 2 to the numerator as follows. And you may see that it amounts to adding 0 exactly. So what I did is I added this part here, which is equivalent to 0. So I have added 0. So that means I didn't change anything, but it's a 0 in a very convenient form. And you may see why. Because I can rewrite it as follows. I can rewrite it as x minus 2 plus, and now 2 minus 1 is just 1 divided by x minus 2, and this can be written as x minus 2 over x minus 2 plus 1 over x minus 2. And you see that the first part, x minus 2 over x minus 2, is just 1 plus, and I have 1 over x minus 2. So the function has this form, so I can rewrite it actually to state the answer as 1 over x minus 2 plus 1. This is the answer to part A, and you may notice that k in this case is the number here, so it's just number 1. Then m is the number which we subtract from x, which is 2 in our case, and n is the number which is added after the fraction, and it's number 1. So if you wanted to sketch the graph of this rational function, all you would have to do is first to imagine the graph of the function y equals 1 over x, so this would be the function f sub 0, and then to shift it by 2 units to the right and by 1 unit to in the vertical upward direction. Okay, and this would be the graph of the function. Now let's continue with part B. In part B we have the function y equals 3x plus 1 divided by x plus 2. So if I want to do something with this, I have to first get rid of factor 3 in front of x. I have to have just the unit factor. So what I do is the following. I take out number 3 in the numerator and get x plus 1/3 divided by x plus 2. Now I will move this coefficient 3 in front of the fraction as follows. It's 3 times, and then x plus 1/3 divided by x plus 2. And in the next steps, I do the same as before. So I try to replicate x plus 2 also in the numerator of the fraction. So to do it, I copy number 3, and now the fraction, I add a convenient 0, so it's x plus 2 minus 2 plus 1/3 divided by x plus 2. And you may see what was added is this neat 0 here. So this is a 0. It doesn't change anything, but it's very convenient for me to have it. So it's 3 times, and now I have x plus 2 as the first part of the expression, and there is minus 2 plus 1/3. So minus 2 can be represented as minus 6/3 plus 1/3. Minus 6/3 plus 1/3 is minus 5/3. Minus 5/3 divided by x plus 2. Okay, so now I can continue in the following way. It's 3 times, and now I use the brackets, and it's x plus 2 divided by x plus 2 minus 5/3 divided by x plus 2. And you may see that this first fraction here is just 1. So it's 3 times, square bracket, 1 minus 5/3 divided by x plus 2. Okay, now I multiply everything by number 3 to get 3 minus, and when I multiply by 3, I multiply just the numerator of the fraction, and I get 5 over x plus 2. So you see that the function y, the function f can be expressed as y equals minus 5 over x plus 2 plus 3. And this is the answer to part B. And you may notice that k in this case, this number here, is minus 5. So it means that the graph of the original function f sub 0, which is in this case y equals minus 5 over x, that the graph of this original function that we are going to shift will sit in the second and in the fourth quadrant, and it's shifted by m, which is negative 2, because this number here is just x minus minus 2. So it's shifted by negative 2 units, so actually by 2 units to the left, and n equals, sorry, let me write it better, n equals just 3, so the graph of this original function has to be shifted through 3 units upwards, and this would be the graph of the original reciprocal function. Okay, let us get on with part C. So part C, we have in part C, let me copy it, we have y equals 2x minus 9, y equals 2x minus 9 divided by 3 minus x. So here, first what I have to do is to change the order. So since these functions in the numerator and denominator should be linear functions, it's good to have first the term with the variable. So variable term should go first, and then there should be a constant term. So it's 2x minus 9 divided by minus x plus 3. So I just replaced this by what it is, but in a different order. Now I will do the same trick as before. Number 2 should be taken out in the numerator. So it's x minus 9 halves divided by minus x plus 3. Okay, now perhaps it would be a good idea to take out negative 1 in the denominator also. So it's just 2 times x minus 9 halves divided by minus 1 times x minus 3. And now you see that it can be rewritten by taking out number negative 2 in front. So it's negative 2 times, and I have x minus 9 halves over x minus 3. So this equals to negative 2 times. Now I will try to replicate the denominator in the numerator. So it's x minus 3 plus 3 minus 9 halves divided by x minus 3. So this minus 3 plus 3, it amounts to a convenient 0. So it's a 0 actually, added to the numerator of the fraction. It doesn't change anything, but it's very convenient for us to have it. So it's minus 2 times, and we have a fraction with x minus 3 in the denominator, and here we have x minus 3, and then we have 3 minus 9 halves. So 3 can be imagined as 6 halves minus 9 halves, so it's minus 3 halves. So 3 minus 9 halves is minus 3 halves. Okay, now I will use a bracket, so it's minus 2 times. So it is x minus 3 over x minus 3 minus 3 halves over x minus 3, like this. So it equals, so it's minus 2 times, so this first fraction is just 1, minus 3 halves over x minus 3. Okay, now I multiply back by negative 2, and I get negative 2 plus 3 divided by x minus 3, because you see when you multiply by 2 and the fraction 3 halves changes to just 3. Okay, so the function y, the function f can be expressed as y equals 3 over x minus 3 minus 2. Okay, so this should be the answer. Now, how can we express k, m, and n? So you see that k in this case is 3. Now m is also 3, and n is negative 2. So the function that we are going to shift, f sub 0, has the form y equals, it's the reciprocal function, and it's the function y equals 3 over x. And this function, the graph of this function, will be shifted by or through 3 units to the right and through 2 units downwards. And this should be it. It should be the solution to this exercise.